guys, we're moving into chapter 2, and in chapter 2, section 1, we're talking about slope-intercept form of an equation. So chapter 2 is all linear equations, specifically graphing them and the different types. So we're starting off with the slope-intercept form, which is the most basic of all the forms. And that is written as y equals mx plus b. Okay, so that is the standard form for slope-intercept. Y equals mx plus b. Okay, now specifically m equals slope. So the slope value goes in front of the x, or is attached to the x, or is multiplied by the x. That's where the slope is located. Okay, so when you get something in slope-intercept form, you can always go to whatever is being multiplied by the x and say that is what the slope is. Okay, now when we think about slope, slope is how steep a line is. So if we look at these three lines here, 1, 2, 3, okay, this one would be the steepest. So this one would be the highest slope. This one would be the middle, this one would be the lowest slope. It's almost totally flat. So for example, and I have no idea what they might be, but this one might be 6, this one might be 3, and this slope might be like 1/5, okay? So your slopes, the steeper they get going up, the higher the number. And the steeper, if we're talking about going down, okay, the lower the number. This one over here might be -5, and this one might be -1/2. Okay, so the steeper going down, the lower the number for the slope value might be. Okay, but again, the m represents slope, and it is always located right there in front of the x. Okay, and that other variable b represents the y-intercept. So that is where our line crosses through the y-axis. And in case we forget what the y-axis is, all right, we have our coordinate plane. The x-axis goes left and right. The y-axis goes up and down. Okay, that's the origin right in there, always 0, 0. And we have tick marks like this. So we have a line that's going to be going up, it might be going down, okay? And wherever it crosses through the y-axis, so if it crosses here, it crosses at 0, 1. So that means that whatever that y value is, when the line crosses through the y-axis, that is the y-intercept, or the b value. So again, if you are given something that looks like this, y equals 1/2 x plus 3, you can look at this equation in slope-intercept form and say the y-intercept is 3.
Please report to the main office.
The y-intercept is 3, positive 3 because it's plus 3. That's the b value. And the slope is 1/2. That's how steep my line is. So that's that, and that's that. We're just looking at it and drawing that information out of it. Okay, so if we're given a problem like this, y equals 4/5 x plus 2, and we're asked to graph, we need to do a couple things. The first thing is always graph the y-intercept. And in this case, it's plus 2. So that means that we're graphing the y-intercept. We're putting a point at 0, 2. So over 0 and up 2. This is where our line crosses through the y-axis. Because remember, that's the y, and that's the x. Okay? The second thing we do is use the slope. Okay? Now, we haven't completely talked about slope, but the slope, as we said, is whatever is attached to the x variable. Okay? So if it's 4/5, okay? So slope is also the m. People always ask, why is it m? Well, you can think of it in terms of mountains, all right? A lot of math comes from Greek and Italian languages. So m equals 45. M is, speaking of that, change in y over change in x. Delta y over delta x, which just means how much the y changes by. So in this case, the y changes by 4, positive 4. Okay? Now, if we look at this, the y goes up and down. So that means the y changes by 4, it goes up by 4. And the bottom means the change in x, which means if it changes by 5, it goes over 5 to the right. Okay? Change in y over change in x. Another way you might see it is rise over run, just meaning that the top goes up and down and the bottom goes right or left. Okay? So because we have a positive 4, we're going to go up. So up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So we're going to meet that point 1, 2, 3, 4, and over 1, 2. So we're going to meet right here, up 4 and over 5. So it's up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Here we are. That's our second point. Okay? And the slope works continuously forever. So we could go and we have to make it a little bit bigger. So we would go from here up 1, 2, 3, 4 again, and over 5. If we do it correctly, it should still be on the same line. Okay? So it starts off with graphing the y-intercept, whatever this number is, 0, comma, that number. If it's negative, then we would go down. Okay? Graph the y-intercept first, use the slope to make a couple more points. Okay, now if we're asked to graph an equation like y equals negative 3x minus 1, well, again, we're going to start off with picking out the y-intercept. In this case, it's going to be 0, comma, negative 1. Because the minus, it makes it negative 1. Okay? So in our graph here, we are going to need to put it at 0, comma, negative 1. Now we take our slope. This time it is an integer. So our slope is negative 3, which means it's a whole number. But any whole number can be put over 1. Okay? So change in y over change in x, so we have a negative 3 over 1. So because the top is a negative, it goes down 1, and the bottom is positive, it goes to the right 1. So we're talking about going down 1, 2, 3, and over 1. And again, we can do it again, down 1, 2, 3, and over 1. Now, some mistakes people often make is that they always graph the first point at the origin. The first point is the y-intercept. Another mistake people make is they might graph the y-intercept correct, but then when they use the slope, they go back to the origin. So they might start counting down from here. But the slope is from one point to the next point, from one point to the next point, and on and on and on, forever and ever. Okay? So slope is from one point until the next. Okay, next thing you might be asked to do is give the equation of a line that's already graphed. Okay, so when we're doing this, all right, we need to find out the slope, we need to find out the y-intercept. So again, the y-intercept, because we're trying to fill in y equals mx plus b, all right? So we're trying to fill in the m, and we're trying to fill in the b. The x and y are going to stay there. So if we think about the y-intercept, we just need to find where it crosses along the y-axis. And it crosses right here. And where is this located? It's located at 0, comma, negative 2. So we know that we're going to have negative 2 in our equation. Now we need to find the slope here. Okay? We need to find the slope. Okay, so we need to find the slope. So where this point is located is 0, negative 2. This one is located at 2, comma, negative 1. So there's many ways to talk about slope. And one of them is that slope is equal to y2 minus y1 over x2 minus x1. Okay? So really what that means is the second y and the first y. Second x and the first x. Okay? So if I want to call this the first one and this the second one, okay, my y2 is actually negative 2. Okay? So negative 2 minus my y1, which is negative 1, over my x2, which is 0, minus 2. I actually did this backwards from how I originally wanted to do it, but it doesn't matter because it'll still come out the same way. All right, so if I call this my second one, that my first one is what I actually did. So negative 2, take away negative 1, and 0, take away positive 2. So what that gives us is minus negative plus a positive, so we end up with negative 1 over 0 minus 2 is negative 2. Okay, so slope says negative 1 over negative 2, but whenever we have a negative over a negative, we make that a positive over a positive. Okay? And just to show you what I talked about that I made a mistake, but I still got the right answer, is because this point comes second, normally I would call this the second point. So y2, which is negative 1, minus y1. So this is me just doing the same exact problem, x2 minus x1. Okay? So what happens here, negative 1 minus negative 2 becomes positive 1 over 2 minus 0 is 2. Becomes 1/2, which is exactly what we got once we made a negative divided by a negative a positive. Okay, so it'll work either way. One way, in this case, because we had a positive, it's the same thing as a negative over a negative, but we write it, our final answer, as a positive. So let's try one more of those problems. And by the way, if you have graph paper, I would use it for this whole section. If not, you're just going to get a lot of practice with making these tick marks. And you want to be as evenly spaced as possible. Okay? So if we look at this one, our y-intercept is at 1, 2, 3. So we know that we are going to have a positive 3. Okay? Now I can tell that I'm going to have a negative slope here because as I go from left to right, just like we're reading a book, you go from left to right, it comes down. So I know I'm going to end up with a negative. Okay, so we know that this one is located at 0, 3. This one is located at 1, negative 1. So let's call this the y2 and x2 one. So again, y2 minus y1, slope equals, and x2 minus x1. Okay, so if I take my y2, negative 1, minus my other y, which is 3, y minus y. So because I did this one first, I need to take this x first. 1 minus 0. Okay? So negative 1 minus 3, add the opposite. I end up with negative 4. 1 minus 0 is 1. So my slope is negative 4 over 1. And a negative divided by a positive is a negative, so we're going to leave it negative. Y equals negative 4x plus 3. Okay. Would I have come up with the same answer if I went the other way? If I did 3 minus negative 1 and 0 minus 1, I absolutely would have. It would have come out to have been 4 over negative 1, and a positive divided by a negative is still a negative. Okay, so I knew looking at this that it was going to be negative because it goes down from left to right.